Right. Hello, NLP Summit. My name's Alex Chow. I am currently a product manager inside the office of the CTO at Microsoft. I'll be talking about cooking with the semantic kernel, recipes for building chatbots, agents, and more with large language models. So I'm sure everyone has seen from Microsoft's recent announcements about CoPilot, your everyday AI companion. And it is very much a key strategy and key product that Microsoft is building and promoting across all of enterprise. So very much so, if you're interested in building these type of copilots and what they mean for you, well, you're in good luck. Because copilots are starting to show up everywhere, right? Whether you're in Word, whether you're in Paint, even on your future Surface device, these copilots are meant to kind of be alongside you and work to really make you more productive and allow you to do more with less. But the context of this situation or this scenario that we're in is, right, where are we, right? The copilots are an AI technology, and the history of AI and how things have shown up so far is AI has kind of been in this bucket of research and not really seen as much of it inside of true like production workloads. But when ChatGPT came on the scene in just less than a year ago now, it really sort of opened people's eyes to what's possible with AI. And the number one use case that we're seeing across Microsoft and also just third party is being able to chat with your data, have that ChatGPT like experience on your own enterprise data. Well, in order to build this though, and you're building copilots, what we found inside of the office of the CTO was that, and we had early access to GPT-4 before it was broadly available and announced, and we actually found that using that model really sort of unlocked brand new capabilities, and it demanded a new way of actually programming. Creating these sort of projects and products inside of Microsoft, we found that the new way of LLM AI programming really is maybe unfamiliar, maybe not super intuitive, at least if you're coming from a traditional software engineering background, right, where things are very explicit, very declarative, and you have more deterministic output and expectation for you write code once, you execute it, and it will do the same thing again and again. But in the world of large language models, that's actually quite different, right? We see that there's a bunch of new terms that are coming out, whether that be tokens, temperature, and even just overall dealing with non-determinism or probabilistic type outcomes. And how do you build with that? How do you design against that? How do you incorporate that into your apps and even your copilots? Well, the encapsulation of that actually came into what we're calling the semantic kernel. But even before all that, right, I think a very common question and a very sensible question that people can ask is, well, why can't I just call the model API itself directly, right? Treat this as any other API and just call it and bring it into my application. I think that's certainly still very feasible, and you can get a lot of mileage out of just interacting with models like GPT-4. But in our exploration of this, we found that you actually start hitting a wall, right? Especially if you want to build more complex type applications, more involved copilots, you'll start seeing the limits of just calling an API by itself. And some of that is reflected in, well, there's no memory built into these models inherently, right? These models are stateless machines that you send in your prompt and get an output back. They also have this notion of a knowledge cutoff, which mostly reflects that these models were trained up to some point on some frozen data set, and they only have knowledge up until whenever that last most the last piece of data was submitted. So that is also a challenge, especially if you want to bring more relevant, up-to-date information into your application. And that also points to this other problem where these models can also be very confident in giving the wrong answer, and that's commonly known as hallucination. So taking all these challenges, taking all these, the new way of programming, we found that you really do need a new set of tools, a new framework to at least help you along this journey, to make you more productive and really get you up to speed with using AI. And the sort of applications that it unlocks is stuff like infinite chats, where you can have a chatbot over long-running memory, over long-running interactions. Picture you being able to chat with your AI, and it remembers stuff about you that you talked about a year ago, 10 years ago, and whatnot, right? We as people, we can remember how we interact with others, and even just recall kind of obscure facts from a long time ago. The AI should be able to do the same, right? And if you have long-running tasks as well, where you involve multiple steps, multiple interactions with an agent or that sort of thing, then you definitely need the tool set to be able to do all that. So hence, we're to deliver this sort of solution. Microsoft at their most recent Build conference announced the CoPilot Stack, and this CoPilot Stack really encapsulates this idea that, yeah, if you're wanting to build copilots on top of a foundation of models, of AI infrastructure, you really need this middle layer, this notion of AI orchestration, to really help you really accelerate and bring and even like stitch together with skills, plugins, connectors, and even using different models for explicit purposes. So all that is wrapped up into whatever end user experience or application that you provide. And yeah, if you want to build all this in a coherent, hopefully tried and true way, well, the CoPilot Stack is there for you. So it's with all this that we bring in the Semantic Kernel. So the Semantic Kernel is open source since early March, and we've very much have wanted to actually grow with the community. We recognize at Microsoft that we don't have all the answers in AI, and we're trying to see and tap into really the innovation that's happening broadly outside of the company, and really have people participate. It's really the wild, wild west right now in AI, and really would want to learn from everyone. So the repo is on GitHub, fully open source, and we have many ways for people to get involved in the community. But what is Semantic Kernel? Well, Semantic Kernel is a lightweight open source orchestration SDK that lets you easily mix and match AI prompts with conventional programming languages like C#, Java, and Python. Put another way, right, it lets you interact with large language models and other foundation models, and lets you still write your native code that you write in your preferred language, and allows you to also then start incorporating these AI elements as well into them. So put all together, these abstractions, these sort of best practices that Microsoft has learned in building their own copilots, it's all put inside this semantic kernel. So one of these pieces that came out actually is from Sequoia, is that in the generative AI landscape, there's often a separation between the application layer and the model layer. And that is very much resonant to us. And where semantic kernel fits in is, right now, it's not about fine-tuning of models or training new models from scratch. I think there are many other products and projects out there, open source projects even, that are better suited for that specific purpose. But if you're an application developer who doesn't know much about AI or isn't at the level of sophistication as a researcher or data scientist, you still want to be able to participate, right? You want to be able to build applications on top of these foundation models. And again, hence the semantic kernel coming in to hopefully, right, materially improve the outcomes that you're looking to have. So if we're going to dive a little deeper inside the semantic kernel, in terms of the core architecture, right? Well, it all begins with this user ask, that comes into the kernel that it's the kernel's job is to try to fulfill that ask or fulfill that goal, right? Goal-oriented programming or goal-oriented AI. And the kernel will take that ask and either deterministically run a workflow or a set of functions, a chain of functions that you've predefined, or it will actually use planning, which is a key part of the kernel, to be able to have AI do this sort of orchestration, skill selection, plugin selection for you. So either way you go, right, the kernel will use what you've set up for either deterministically running a set of functions ABC or having planning do this kind of really magical sort of thing where it will take what it thinks are the appropriate steps to solve your goal. So, a very natural question about, why use semantic kernel in the first place? Well, like any SDK, it really is meant to really help you build things in a consistent way and ultimately avoid future tech debt, right? I think we're in this time in AI where a lot of applications are being built, a lot of demos are being built. Many times these people are writing code once, discarding it, writing something very similar again, and having to just redo or reuse a lot of things. And in that scenario, in that world, right, you benefit a lot by having an SDK like the semantic kernel so that you can have a paved path for whatever sort of AI application you're looking to build and deploy. This idea of being able to not only just interact with the model by itself, right, just through prompt-based engineering, you also, with the semantic kernel, can leverage the best of both worlds, right? You can use your native code that you've already written, the code that's inside your enterprise that connects to all these different APIs or data sources, and combine that with the kernel to unlock brand new scenarios that you weren't able to do before. So there's this other side of, right, if you want to incorporate memory or have better context in the type of interactions you're having with, let's say, a chatbot or whichever, an agent, right? You want to be able to have that state. You want to be able to have memory that can allow you to, just have long-running tasks, have it be able to fetch, have it be more contextually aware and more grounded in its responses. So as we kind of dive deeper into one topic in particular for the kernel, I wanted to call out this blog post from Lillian Wang. Lillian Wang is from OpenAI, and she wrote this post called LLM-powered autonomous agents. And if you look at this diagram, you'll see that the agent is at the core of it, but it makes use of several things. One is tools. So these tools are either functions, APIs, connectors. But the idea is that the agent can interact with the outside world. The AI not only has knowledge or things baked into its own weights, but once you give it access to tools, it can do a lot more. The other pieces I already mentioned, memory, right? If you want to incorporate both short-term memory, long-term memory, there are many different and very interesting strategies to be able to accomplish that. These last two, I would say, are more hand in hand, right? But they're also separate, right? You want an agent, an AI, to be able to ultimately do things for you provided it's within guardrails and it's somewhat predictable, somewhat controllable. But before it can take any actions, well, agents and AIs need to be able to plan, need to be able to have this idea of, okay, I'm going to use these set of tools and create this plan for myself, or a blueprint, right, that I'm going to use to execute. And planning involves, as called out here, right, being able to reflect on what you've seen, what you've done, and maybe correct yourself as you see fit. And yeah, being able to also sort of have this chain of thought to at least be able to express its own reasoning. Super important, especially if you want more interpretability behind like why the agent or AI did what it did. So put all this together, it leads into what I would go into more about planning. So in Semantic Kernel, there are three main types of planners that we expose, at least today. It's an interface. More planners can certainly be built and incorporated. But the three that we have right now are Action Planner. So Action Planner, its main job is to, among the functions or skills that you provide to the kernel, it's really meant to just select the single skill, the single function that is appropriate to achieve that goal. And I'll talk more about this inside a demo, but that's its job, right? The Action Planner is mainly just meant to do or select one thing. Sequential Planner is actually one where you start stitching together multiple skills, doing multiple tasks, multiple calls to the large language model to try to achieve the goal, try to fulfill the ask. And I think it's most natural because in sequential planning, you take the output of one skill, one function, and you pass that in as input to the next one. So it's very much being able to operate in a directed flow or in just a sequence. And it's very much how you can imagine just an agent or an AI just solving a problem. But in my opinion, the most interesting planner among these three is the Stepwise Planner. So the Stepwise Planner, its job is to, again, take that ask and plan it and execute step by step. But it has built into it this notion of reflection or observation, where it will make a thought, make a sort of plan internally about like, okay, in order to do this, I need to take these set of steps. Well, it will even take those steps and then observe like what it's done, what it receives back, and either continue going or correct itself to say like, hey, maybe I need to go back to the drawing board and get even more information or do something differently than I did. So Stepwise Planner is meant to capture this type of more critical, more observant, more reflective type of planning capability. All right, so if we go into the demo, and this demo is actually just based off of the notebook, one of the Jupyter notebooks inside the Semantic Kernel code base, and there's a Python version of it. But yeah, if you want to follow along, definitely invite you to clone the repo and try running these. But as I mentioned, right, for planning, it all begins with the user ask. So in this case, the ask is, tomorrow's Valentine's Day. I need to come up with a few day ideas. She speaks French, so write it in French, and then convert the text to uppercase. Well, before doing anything, right, we need to give skills to the kernel and have the planner be able to see all that. So this syntactically is just through importing it directly into the kernel. So in this case, we're bringing in a summarize skill, a writer skill, a text skill, and within skills or plugins, we're actually calling them plugins now. They incorporate many functions inside of it. So and each function is a prompt or native code that you've written. And yeah, they're all brought into the kernel and available to use at runtime. All right, so in the Python version, there's this notion of a basic planner, which is actually very much similar to a sequential planner. I'd invite you to read the prompt behind it if you look at the code. But basically, right, you see this where the plan that's created is actually just JSON. It's a JSON readable object that shows you for that ask. So remember, we're trying to come up with some data ideas where it will take this input and then start calling or start showing several subtasks, right? Different functions to call and even the arguments to call them. So you'll see in this case, it will take this Valentine's date date ideas and pass it to a brainstorm skill or brainstorm function inside writer skill. It will then have this email to function as well, and even a translate one. If you remember, we're trying to translate to French and then convert all this to uppercase. So in this case, the plan seems very reasonable, and we can go ahead and execute it. So before we actually do execute it, I wanted to just show off, like, okay, what if I wanted to sort of modify the ask syntactically? What does it look like to create a new function and bring that to the kernel? Well, we can do this in just a single line with a prompt. And yeah, in this case, we created this Shakespeare function where its job is to rewrite the above text that you provide into the style of Shakespeare. So now if we just go back to modify our ask, where I say that, oh, my significant other likes Shakespeare, so write using his style. You can see that reflected in this new plan that's created. And now when you execute this plan, right, these are two separate steps, at least in the semantic kernel, where you create a plan, you verify that it looks good, and then you actually execute it. So in this case, it created this list written in French. Unfortunately, I'm not a French expert, so can't verify it super well if it's good. But I think it kind of gives you the idea, right, that this is what planning and execution looks like. So I talked about sequential planner. In contrast to the basic planner in Python, that one is more JSON based, whereas the sequential planner is XML based. And I call this out because to our discovery, right, the model GPT-4 and these other large language models, they're very good at just reading and producing even structured output, things like JSON or XML. Definitely sometimes you can run into trouble that the output may not be well formatted. So that's where having guardrails or some other projects like TypeChat from Microsoft kind of come in to provide more of this at least guarantee or at least higher probability output that the stuff that's coming out from the large language model is of good quality. Well, Sequential Planner is, again, XML based. You can check out the prompt to read more. But it is very much like, I'm going to create a plan. These are the steps. I'm going to execute these things in sequence. Action Planner, as I mentioned, is all about giving that single function, giving the planner the ability to just choose one single function that's appropriate for the goal. So in this case, where I have many functions or skills imported, right, I'm calling this planner to fulfill this ask of what's the sum of these two numbers? Well, it's going to take all this and say, okay, inside the math skill, I'm going to grab hopefully the addition function. And if I run this, right, it will actually give the proper addition result. So Action Planner, super useful if you're really just looking for one function to call. All right, so Stepwise Planner, and as I mentioned, this one's the one I'm personally just most interested in. So it's based off several papers and research that's out there, MRKL, or Modular Reasoning, Knowledge, and Language, as well as the React paper, Reasoning and Acting in Language Models. These are great sort of examples for us because they show us how you can use the AI to form thoughts and observations and ultimately execute those things based off the user's goal. So in this case, I'll just show off a quick web search skill here. The implementation is not super important, but the idea is that this will allow the kernel to call Bing. And then I bring that to the kernel, import that along with some other skills. And now I'm going to present this ask where it's how many total championships combined do the top 5 teams in the NBA have? Well, you can see you probably have to do a bunch of different steps to arrive at that answer, unless you've already memorized it off the top of your head. So do we see the result comes back with 49 championships? Well, let's just see like how it got there, right? If you see this printout, you'll see several thoughts, several actions, and several observations. And the thoughts are, the AI is going to say, okay, in order to fulfill this, I need to do these set of things. I'm going to use this search to query something and get those results back. Now, if you run it several iterations, it will at some point say that, okay, I've received enough information. Now I'm going to try to like solve the problem. And you can see these are the steps it took to ultimately come at the answer 49. Well, the question is, what's the actual answer? So as of September 2023, the top 5 well, I'll first call out that the original question could maybe be misinterpreted. I think top 5 teams could be ambiguous, but if we're just looking at number of championships, well, I think that's more of a objective measure. So I just took all the actual numbers that are out there, and the answer is actually 52 championships. So I think this just calls out that even stepwise planning can be wrong. I put to the side an example of Bing, kind of even trying to answer that question itself also. And you can see they give the answer 42, which again, is not correct. So in short, right, the TLDR is that we still have quite a long ways to go. All these great planning capabilities, all these things are awesome, but a lot of open challenges still remain, right? There's a lot of things that you have to think about, you have to prepare for, you have to iterate and experiment with. And, doing all that is challenging, but one amazing thing is that we're able to do this all in community. So for Semantic Kernel, we have a Discord channel that you're more than welcome to join and participate in. I guess quick shout out for myself. I also have some content if you want to just watch more Semantic Kernel, hear some interviews, join office hours. That's all available on my own personal YouTube that you can check out. At the very bottom, I also call out I have my own podcast, The Humans of AI, where I talk to people about their stories in building in AI or actually just experiencing it. So definitely welcome for people to check that. And of course, right, if you're looking to connect, if you want to just chat more, feel free to reach out. I'm on Twitter, I guess X now, LinkedIn, YouTube, and I even have my own newsletter, which you can subscribe to. So with that, right, I want to just thank everybody at the NLP Summit for listening, for checking us out. And yeah, definitely let us know your feedback on Semantic Kernel. And thank you, right? Thank you for helping everyone exceed their goals. All right. So with that, I will hand it off.
As today's session come to a close, I want to say thank you to all of our speakers and all of you for shedding light on the most recent breakthroughs in AI. I would like to thank each one of you for your engaging questions and for sharing your experiences. It's evident from our discussions that open source efforts play a pivotal role in applying NLP and LLM techniques in practice. The range of tools and models presented today, tailored to tackle real-world business needs, is truly inspiring. The accomplishments of the open source AI community in 2023 have definitely been impressive, and by all accounts, we are just getting started. We reconvene tomorrow at noon Eastern Time for day 2 of the NLP Summit 2023, with a spotlight on the role of NLP and LLMs in healthcare. We invite you to rejoin and be part of this ongoing discussion. Wishing you a pleasant evening and looking forward to our discussions tomorrow.